Hello, it's Keith from Kinvert, and in this video we're going to go over how to find out if a point is on the graph of an equation. And in this case, our equation is y equals 2x plus 3. We're given 3 points and we want to find out which 1, 2, or 3, maybe all of these, maybe none of these, are on the graph of the equation. The first is 2, 7, where x is 2 and y is 7. Then we have 3, negative 8, and 3, 6. So first what I want you to do is think about one of these points is definitely not on this graph, okay? One of them is clearly not. I'd like you to think about which one it is and then pause the video and try to decide which of these 3 points is not on the graph of the equation 2x plus 3. So you can hit the K key to pause the video, and I'm going to get you the answer here in 3, 2, 1. So the point that is not on the equation of 2x plus 3 is 3, negative 8. And the reason is that if x is positive for this particular equation, then y also needs to be positive. And that's because 3 is the y-intercept and the slope is positive. So we know that this one isn't going to fit. And we'll also graph this soon. So I'll go ahead and actually put this point. It's in red. So 3, negative 8 would go right here. All right, so now let's start looking at 2, 7. So we're going to make this one, how about we make it light blue for this? And so for the x value, we're going to have a 2, so I'm going to put a 2 here. And then I'm going to do the rest in orange like this. So 2 times 2, see how I replaced the x with this color blue? Let me go ahead and put this here to show that we're using blue here. All right, so 2 times 2 plus 3. So we can evaluate that. And 2 times 2 is 4, and 4 plus 3, so we have 7. So this equals 7. And if we look at this, the x value is 2, which we have, and then the y value is 7, so this one should be on the curve, on the graph of this equation. Let's take a look at the next one. Now, actually, if we look at this, we can make a prediction. We can see that the x value got bigger for this one, and yet the y value got smaller. So I want you to think about whether or not that's going to be on the curve. So first I'm going to graph this equation. So we have one of the points that's on the equation, and that is 3, 0. We know that that's going to be one of the points because if x is 0, y is 3 because that's the y-intercept. The other one we've got is 2, 7. So 2, 7. And so now we can actually graph this line through those points. You can see that that line goes through the points. And now what we're going to do is graph out this 3, 6. Now that we found one analytically, let's find one graphically. So 3, 6, where's that going to go? I chose purple for that. So we're going to go 3, 1, 2, 3, and then up 6. So we can see that we're lining up with 6, and we're lining up with 3 for this point. And you can see that it is not on the graph of the equation 2x plus 3. So this is Keith from Kinvert. We went over how to find out if a point is on the graph of an equation. In this case, we did 2x plus 3. One way that we did this is by actually substituting in the value for x. So we put 2 instead of x. So now it becomes 2 times 2 plus 3 instead of 2x plus 3. And this was 7. And the y value of this point was also 7. So this one checks out. This one we could actually eliminate early on because we can see that the positive y-intercept and the positive slope means that any positive x value should correspond with the positive y value. In this case, it didn't. We know that this point is not on the graph there of the equation. And then we get to 3 and 6. Now this one, for a couple reasons, we knew it's not on the equation, and that is because the x value is higher, but the y value is lower. But this is a positive slope. So for that one reason, for example, it can't be on the graph of the equation. And then another reason is we graphed the line of 2x plus 3, and then when we put this point on the graph, we could see it does not fall on that linear equation line. So I hope this was helpful, and we will see you guys in the next one. Bye.